Consider the context-free grammars over the alphabet A, B, C given below. S and T are non-terminals. G1 gives S gives A, S, B or T. T gives C, T or epsilon. G2 is S gives B, S, A or T. T gives C, T or epsilon. The language L of G1 intersection L of G2 is, and these four options are given. So we have been given two grammars here, G1 and G2, and we need to take the intersection of these grammars and find out what the final language is. So this is a question from theory of computation regarding grammars, regular grammar, context-free grammar, etc. So we will look at these two grammars and try to gain more intuition into this as to what these grammars are, and then we'll take the intersection of it. So let's look at G1. G1 says that it gives S gives A, S, B or T. So in this part there is one more S. So we can keep on taking this part, S gives A, S, B, and this S, we can keep on resolving it to A, S, B, etc. until we resolve this S to a T. Now once we do that, there is no more S, and then T we can generate independently here. T gives CT, independent of S, I mean. T gives CT or epsilon. So this part will be C star. If you see, T can be epsilon, T can be 1C and T, which can be again 1C and T, etc. So this is C star, 0 or more C's. Similarly, if you take a look at G2, this is generating BSA. We will keep on generating BSA until we resolve S to T, and after that T will be C star only. So G1 will look like this: A raised to N, C raised to M, B raised to N, such that N, M greater than or equal to 0. If you look here, it is generating equal number of A's and B's, A to the left, B to the right. It will keep on generating it like that until we reach 1T. That T will be C star. That is what I have written here. N number of A's, then any number of C's, and then N number of B's. Number of A's and B's would be equal. Similarly, G2 we can write as N number of B's, then M number of C's, and then N number of A's. Nm is greater than or equal to 0 in both the cases. Now G1 generates two types of strings here. If N is greater than 0, it generates strings starting with A. And if N is equal to 0, N is this part. If N is equal to 0, it will generate C star, that is 0 or more C's. Similarly, in G2, if N is greater than 0, it generates strings that start with B. And if N is equal to 0, it will generate C star. So if you see, for N greater than 0, strings starting with A, there is not even a single string in G2 starting with B. So G1 intersection G2 will eliminate all of these strings. Similarly, for G2, if N is greater than 0, it starts with B. There is not a single string in G1 that starts with B. So taking intersection, all of these strings will also be eliminated, meaning only these two strings will be left. If N is 0, it is C star. If N is 0, it is C star here. So intersection will generate, these two are equal here. So intersection of language of G1 and language of G2 will be giving us this part only, that is C star. So L of G1 intersection L of G2 equal to C star. Now C star is a regular language, but it is not finite. So the answer is B, not finite but regular.